Hi, I'm Gwanghyun Kim. I'm going to present our work DiffusionCLIP, text-guided diffusion models for robust image manipulation. In this work, we deal with a text-driven image manipulation task. The manipulated image should highly correspond to the target text, as well as preserve identities without unintended changes. Also, the framework should support diverse types of text prompt and diverse types of image domains. Recently, to achieve this goal, CLIP and GAN inversion methods are combined. In CLIP, a text and image encoder are trained to identify which texts are matched with which images in the dataset. And GAN inversion is the method for finding a latent vector corresponding to an input image given pre-trained GAN generator. Combining these two methods, inside CLIP and static nada, latent or generator are updated guided by CLIP loss, enabling text-guided manipulation without additional manual efforts. However, even the state-of-the-art inversion methods fail to reconstruct images with novel poses and details, and reconstruct images from a dataset with high variance, generating distorted manipulation results. To overcome these issues, here we propose DiffusionCLIP, a clip-guided robust image manipulation method by diffusion models, which shows high-quality image synthesis as well as near-perfect reconstruction performance between latents and images. Diffusion models are consisting of a forward and reverse process. The forward process is a fixed Markov chain with Gaussian transition, where noise is gradually added to the data. The reverse process is parameterized by another Gaussian transition, where the sample is iteratively denoised. In practice, a noise approximation model epsilon is trained with the following objectives. After training, the data can be sampled stochastically using the value process. In DDIM paper, the deterministic sampling process is proposed. We adopt the deterministic DDIM forward and reverse process to guarantee near-perfect reconstruction between latents and images. In DiffusionCLIP fine-tuning, the input image is first converted to the latent with pre-trained models. Then, guided by the CLIP loss, the diffusion model at the reverse path is fine-tuned to generate samples driven by the target text. We use the following objective composed of directional CLIP loss, which is robust to the mode collapse issues, and the identity loss. To accelerate the fine-tuning and inference procedures, we perform the forward diffusion up to T0 smaller than the last time step. We can further accelerate the procedures by using fewer discretization steps. Once the diffusion model is fine-tuned, any image from the pre-trained domain can be manipulated through forward DDIM with original pre-trained models, followed by reverse DDIM with fine-tuned diffusion models. Qualitatively, our method shows outperforming results compared to SOTA GAN inversion-based baselines. Specifically, GAN inversion methods fail to manipulate face images with novel poses, producing distorted results. Furthermore, in the case of church images, the manipulation results can be recognized as the results from the different buildings. On the contrary, our reconstruction results are almost perfect, even with fine details and background, which enables favorable manipulation. Quantitatively, diffusion-based reconstruction shows superior performance to SOTA GAN inversion baselines. Also, in the human study results, manipulated images using DiffusionCLIP were preferable to baselines. Furthermore, from the non-subjective evaluation results, DiffusionCLIP demonstrated high attribute correspondence and well-preserved identities without unintended changes. DiffusionCLIP moves a step forward to general text-driven manipulation, enabling manipulation in various domains including dog face, bedroom, and even extremely widely varying ImageNet. We can even translate the image from an unseen domain into another unseen domain bridging two domains. Furthermore, by combining the noise predicted from several fine-tuned models, multiple attributes can be changed simultaneously through only one sampling process, and also enable interpolation of certain attributes smoothly. Thank you for your attention. I was Gwanghyun Kim, and play with our code and demo in the following link.